8.4 is looking at the pH scale. The pH scale is how we measure the strength of an acid or a base. There are two calculations in which we can use in order to determine the effects of the acid and or the base. We have pH equals the negative log base 10, which is traditional in your calculator, times the concentration of your hydrogen ion. So you would use this equation if you knew your hydrogen concentration and you were looking for your pH. If you knew your pH and you're looking for your hydrogen concentration, you can then do the calculation of 10 to the negative pH, which is the inverse of a negative log base 10. Now, where does this p-value come from? When the scientist back in the 1800s was looking at the strengths of acids and bases, he decided to use the letter P with really no reason behind it, but essentially we believe the translation of what it means is power. And by power, for us, we mean magnitude, which is why we have 10 in this value, and the calculations always show the magnitude. pH is technically a negative number to which the base 10 is raised, in which to give the actual value of the hydrogen ions. Some examples of what this can look like. If you know your hydrogen concentration is 0.01 moles per decimeter cubed, that is your concentration. You could, if you wanted, input that value into this calculation. Or you could look at this and turn it into an exponent power. So if we have 10 to the 1, 2, negative 2, that power is your pH. Therefore, your pH is 2. Let's look at the next one. So we have 10 to the 1, 2, 3, 4. Therefore, our pH is 4. pH is used to quantify the strength of your acid. Therefore, which one is going to be stronger is the one with a lower value of pH. So this one has a lower pH, which means it is stronger, which means you have a higher concentration of hydrogen ions. There are three things about pH that are held consistent. pH is usually positive and has no units. Now it has the potential to theoretically be infinite, but most acids and bases fall within a set range that you know of being from 0 to 14. These are just values in which to represent the strength or weakness of an acid. If we were to put this into concentration form, we'd have 1 mole per decimeter cubed to 10 to the negative 14th moles per decimeter cubed. And this represents that the strongest acid would have the highest concentration of hydrogen ions, and the weakest acid would have a tenfold decrease in that, as well as mentioned in the previous slide. The pH numbers are inversely related to the concentration of hydrogen ions, as mentioned in the previous step. So if you decrease your pH number, such as being 0 or 1, you're increasing the concentration of your hydrogen ions, and vice versa, because the presence of hydrogen is what we're measuring with pH, and then pH values go from 0 to 14 as strongest to weakest. We change pH by 1 unit, and that has a tenfold change in your concentration of your hydrogen ions. So if we go from a 1 to a 2 in our pH scale, we go from 10, and I'm just making these numbers up, 10 hydrogen units to 100. Then if we go to 3, that takes us to 1,000, and so on and so forth. Now we've talked about the pH, but there's also pOH. So pH are specifically for acids, pOH are for bases. They both exist, but the equipment in which we have only measures the actual hydrogen ions, which is why we have pH. But because pH exists, there is a relationship with pOH. And it is an inverse relationship. So if we increase your pH value, you're going to decrease your pOH value, so on and so forth. So if we make a stronger acid, there's less base present. If you have more base present, there's less acid present. The scale in which we know is 0 to 14. This is our acid or our pH scale. 0 being the strongest, 7 being neutral, 14 being a weak acid. Well, we also have a base scale for pOH, and it is the inverse, where you have the strongest base as 14, neutral at 7, and 0 for weak. Because of this, we are able to use just one scale because it's an exact inverse. That's why we say from 0 to 7 we have our acid, and from 7 to 14 we have our base, because that is where this is strongest for the 7 to 14, and 0 to 7 is when the acid is the strongest. And because we have this inverse relationship, we can use just one of the scales. There are two ways in which we can measure our pH value. First is using color, and we use these in the form of indicators, which we have briefly talked about back in, which we have briefly talked about in 8.2 or 8.3, can't remember which one, and it'll be further discussed in 18.5. But indicators are used, and there's a color change that occurs at specific pHs, so you can determine at what strength you are at. You also have a pH meter or pH probe, and this is an electronic version that directly measures your hydrogen concentration. Because of this, though, you have to use a calibration technique in which you have to make sure that you have a solution which is calibrated for the probe in which to measure out, because if you change temperature, you change pH values, so on and so forth in equilibrium reactions, and that will be discussed in the HL portion of acids and bases.